Hello, I'm Professor Blake, and this is GDD 210, Lab 3, Materials and Lighting. Please download the GDD 210 Lab 3 Unity project from GitHub to follow along with me. You can find a link on Blackboard. In this lesson, we will examine how Unity renders your art, your 3D models and 2D sprites in your game. Understanding how this is done and how to control it will allow you to give your games the look and feel you're after. In the Lab 3 intro folder of the Unity project, you'll find two scenes. We'll start with the intro 1 scene. It should look like this. So here we have a simple Unity scene with a camera and directional light, some 3D cubes, and a sphere. As you can see, the scene is rather boring. The cubes are all the same color, totally flat and uninteresting. Here in intro scene 2, we have most of the same scene game objects, but with a much more interesting look. The plain gray cubes have all been given new materials that give them interesting textures and even simulate details like depth and occlusion. There are also some real-time and baked lights which help bring the otherwise static scene to life. We zoom back out into the scene view. You'll notice that in the hierarchy for the scene, we have most of the same game objects as the previous scene. The ground is still just a flat cube, but you'll notice the material applied to it with these holes give it some kind of depth effect. The buildings in the back are still flat cubes, but through the material that's applied to them, they appear to have this depth effect, and also the windows that give off light. And then the sphere, again, is just the normal sphere game object that Unity generates, but it's got this material on it. Gives it some texture. You can kind of see the threads of this fabric wrapped around it. Alright, so now that we've seen how powerful materials and lights can be, let's take a look at how they work and how you can use them in your games. Go ahead and navigate to Lab 3.1 Mesh Scene. And here we're going to examine the basics of what a piece of 3D art actually is and how Unity renders our models. In this scene, you're going to find a simple cube floating above the ground, which is another cube, but scaled on the y-axis to be flat. We switch to wireframe mode by dropping down this menu here and selecting wireframe. Unity will draw out the mesh without the faces filled in, and we can see the components of our mesh that actually make up the object. Alright, so here I am inside of a 3D modeling program called Blender, and you can see I've remade our Unity cube. 3D models have several components that they need to be rendered in a program like Unity. If I enter wireframe mode, you can see that this cube looks just like the one in our Unity scene. 3D models are made up of vertices, or points along the edge of the mesh. Our cube has 8 vertices, one at each corner. 1, 2, 3, 4, 5, 6, 7, 8. These points alone can help define the shape, but we also need to know which vertices should appear connected to each other. To represent this, we use edges. These are straight lines between vertices, which further help to define the shape of our model. So all of these lines running between 2 points are the edges. Faces are polygons which appear when 3 or more edges form a shape. In game design, we typically use triangles, called tris. but you might see four-sided faces too, called quads. When we combine the vertices, edges, and faces, we get a 3D mesh that can be rendered in Unity. So now that we've seen the basic components that make up a mesh, you might be wondering how something like the default Unity sphere is made. It doesn't look like it has these components, but if you get close enough, or you switch to wireframe mode, you can see how it's done. Again, like our cube, it's made up of vertices, edges, and faces. Here we have a sphere like the sphere we had in our Unity scene, and you can see that it's got a bunch of faces similar to our cube. The trick with round objects like a sphere is to tell the mesh to shade the faces smoothly instead of drawing hard lines between them. When I set the face shading to smooth, the sphere suddenly appears to lose its faces, but as you can see in edit mode, they're still there. If I select shade smooth, now it appears that the hard edges have all disappeared, but they are still there. It's just a shading technique. Now that we understand the basic components that make up a mesh, we can start to look at how Unity renders them in our games. On our cube, you can see that there are two necessary components attached to the game object: the mesh renderer and the mesh filter. The mesh filter component allows us to select which mesh we should be using for our mesh renderer. Simply click the Find circle and locate the mesh you wish to use. We'll be using Unity's default cube. The mesh renderer takes the geometry from the mesh filter and renders it in the scene. This component allows you to define the material with which to render the mesh, how it will handle lighting, and how blend probes view it. The material field allows you to choose a material to apply. We'll get into these more soon. In the lighting settings of the component, you can set whether the mesh should receive or cast shadows. Materials play an integral role in achieving the look and texture of our models. Go ahead and open the Lab 3.2 scene materials. And here you can see a collection of cubes with different materials applied to them. So I'm going to go through each one and describe what a material is, how to modify them, create them, and use them in your game. So a material is a Unity asset which tells the engine how to render the mesh in the game. This begins by selecting a shader for the material to use. Shaders are programs that tell Unity how to handle the texture, color, lighting, and position of the pixels that make up the object we're rendering. Unity comes with dozens of shaders that you can choose from, each with a specific use case. By default, new materials are created with the standard Unity shader. The standard shader is very robust and allows us to make all kinds of unique materials. It can be used to make simple single-colored materials like this green cube. The material applied to this cube allows it to realistically interact with light so that it produces a shadow, is brighter on the side facing the light, and reflects light towards the camera. Looking at the material asset in the inspector, we can see that the standard shader is selected, and all of these texture fields are empty. There's a color tint option which I've set to this green color, and I've turned up the smoothness to around halfway up so that light reflects off of it, kind of like plastic would. The standard Unity shader gives you many options for tuning your materials, and this is before you even start adding textures. The standard shader is also capable of creating highly detailed and realistic materials, as seen in these objects. The standard shader produces physically based rendering, or PBR materials, which do a great job of replicating the effects various materials have on light. Here we can see the effect of the PBR system in action. This cube, again a simple mesh with 6 faces, appears to have these rounded rectangular holes inset into the surface. The concrete cube also appears to have chunks taken out of its faces with detailed debris resting inside. And the ball of string looks soft with the fibers sticking out above the sphere. All of these effects are created with textures applied through the standard shader's input fields. Inside of the Lab 3.2 folder Materials, I selected the standard PBR material, which is this cube on the left with the round rectangular holes. And here we can see what makes a PBR material look like it does. This material, using the standard shader, has several textures added to the main map's input fields. That's these squares here next to the various field names. Let's look at each field and see how they work. First, I'm going to start with an empty material, and then begin filling in the textures so we can see what they do. I've already applied blank standard shader PBR material to this cube. In the albedo field, we can choose a texture which makes up the color of the material. As you can see, this gives the material its base texture without any depth effects. Using the color tint, you can add color or darkness to the selected texture. This makes it very easy to have varied materials which use the same texture. Next, we will look at the normal map texture. This field usually causes the most noticeable changes in the material because it can create drastic changes in the way light bounces off the faces of the object. The texture simulates areas of bumps and dips so that light bounces off of the surface as if there were a more detailed mesh there. This allows materials to dramatically increase the appearance of details in the model while keeping the resource cost low. Here you can see how the normal map gave our flat texture a bunch more detail. If we select the texture and look at what a normal map texture looks like, you can see this strange color that it uses, where each color tells the material which angle the light should bounce off of it. To create a normal map for your albedo texture, if it doesn't have one, you can look online for normal map generators. You have to play with some of the settings to get them to look right. If you're interested in finding your own textures and creating normal maps for them, here's a website where you can find textures. Some of them have normal maps, some do not. So I'll go through the process of downloading a texture and then creating a normal map for it. First, head to textures.com. They have a lot of free open source textures. Some require attribution, some don't. Just check the license before you use them in your project. So I'm selecting a brick texture, blocks. I want seamless textures only so that the can tile nicely on my models. And I'll grab this one, download it. And then I head over to this normal map online normal map generator. The link's here. You can just Google search it. It's a pretty popular one. So you can click on this first box here, select the texture you just downloaded, you'll see your texture pop up here and then the normal map that it's generating over here. And you're going to have to adjust some of the settings a bit. It's kind of ugly looking right now. You can pull the strength down, maybe blur it a little so it's not so sharp. And when you have one you like, I'm going to turn off ambient occlusion and specular maps because I just want to see the normal. Alright, so we'll say that's good for now. Enter the name you want for it, my normal map, and click download. Now back in Unity, I can create a new material and right click in my assets folder, go to create material, call it my material, and you can see by default the standard shader is selected. This is where you would choose other shaders if you wanted to change them. So to apply our textures to our material, first the color texture goes in the albedo field, called it my texture. And in the normal map field, I'm going to grab the texture I've called my normal map. And it's going to give me a warning if it's not set to a normal map asset type. So I can hit fix now. But what that does is here's my normal map texture. It's just changing the texture type to normal map. And whenever you have a normal map, you want to disable any kind of image effects on it that might make it blurry. So this bilinear filter mode, change to no filter. And that'll keep your colors of your normal map crisp, and then they'll better react with the material and the lighting. So now I have a normal mapped material over here, and I can drag that onto something in my scene, and we now have a new material. So you can see it's not done perfectly, it looks a little strange, but you just have to play around with the normal map generator to get the texture look right. So now that we've looked at the normal map texture and how it affects the material, the next field we're going to look at is the height map. The height map texture defines areas of the texture to raise or lower, creating a surface level occlusion effect. This, when combined with a normal map, can create convincing depth details. So what this is going to do is further create depth on our texture, or height, it could go either way. So I'm going to grab my height map, and you can see immediately it looks like the holes along the face go in farther. And if we adjust the slider for it, we can increase or decrease the effect even more. If we open up our height map texture in our assets folder, select it, you'll see that it's just a black and white image. So the material uses the black spots to create depth and the white spots to create height. So this means it's pretty easy to edit. So what I did as an example is took this image into an image editing program and just flipped the colors. So we have height reversed. So now the squares are white and the lines in between are black. And if we apply this to our material, you'll see that it instantly looks like now we have bumps instead of holes. And again, we can adjust those with the slider. So this is a pretty powerful tool and easily editable, unlike the normal maps, which are a little more difficult to edit manually. The height maps are pretty simple to manipulate. The next field we're going to look at is the ambient occlusion field. This texture map defines how much ambient light an area should be exposed to. So for example, deep cracks in a material that would receive less ambient light should therefore appear darker than the surrounding areas. Okay, using these maps should be enough to get you started on working with realistic looking materials. All the textures I used in this project were found on textures.com, where you can find free to use PBR ready textures like these. The next cube in our scene has the building material applied to it. Like our other PBR materials, this has an albedo, normal, ambient occlusion, and height map to give it loads of detail. It also has something called an emissive map. This is another texture we can use to control the look of our material. An emissive map refers to a texture which tells the material where it should emit light from on the surface of the object. In our building example, you can see that the windows stay bright even when the faces of the mesh are in the dark. This is great for things like windows, computer screens, glowing buttons, etc. They allow part of our texture to appear illuminated and can contribute to the light in a scene. Here you can see the emissive texture for the building. Everything is black except for where we want light to show on the model. So we have the windows with the light areas. Just for an example, I've gone ahead and just pasted the GDD logo over this texture. And you can see when we apply this to the building material, you can see that we get the same effect with the bright logo on our texture. It remains lit even when the face of the material is in the dark. On our next cubes, we have again the standard shader for materials, but on the glass material, as you can see, the rendering mode has been changed from opaque to transparent, which allows light to pass through it. As you can see, we can see the ground texture behind the cube. With the transparent render mode, in the color field, you can adjust the alpha channel, which determines how transparent the mesh should look. There are no other textures applied to it, but the smoothness is turned up, so this gives us a glass look. The cube next to it uses a cutout material. I go to the health material. You can see the render mode is set to cutout. And what this will do is take this texture, which is just a cross. It'll take this material, which is just a green cross with a transparent background on the corners, and it will allow it to be rendered with the corners not drawn, so we can see right through them. You can adjust the alpha cutoff slider here to determine how much alpha is needed to stop rendering that material, that part of the material. Alright, moving on to our next cube, we have the unlit material applied to this checkerboard cube. If we select the material, you'll see that this material uses an unlit texture shader. This is not the standard shader. This is found in the Unlit tab under Texture. And all this does is apply a texture to the mesh. There's no normal maps, there's no lighting on it. It's just going to display this texture. The next cubes we have over here have another new shader on their material. I'm going to start with the blue cube. It has a material called Multiply. And Multiply uses a particle shader called Standard Unlit. So, because it's unlit, you'll see light doesn't have any effect on it. It's the same brightness all around. Particle shaders can have various render modes and color modes that change the effect that the texture has in the world. So this blue one is an additive render mode with a multiply color mode. And you can see that what the multiply color mode does is anywhere that it's overlapping with another color, it multiplies them together and gives you the average color. So here where it's the background texture behind our cube, you get a mixture of the blue cube and the background texture. Where the cubes are overlapping each other, there's pretty much just blue there because it's multiplying those two blue colors together. The additive texture on the yellow cubes, you'll see has an additive color mode. And here we get a addition of colors where they overlap, which will bring it closer and closer to the color white where all of the color values are maxed out. So when we get overlapping additive materials, we get closer to the color white. There's a bunch of options in here. These are something you'll just have to experiment with depending on your application. These particle materials are often used for things like particle systems. If you're making smoke or fire or something, you might want to choose a different material to make it look right. Sometimes an effect like fire, you want to get brighter and brighter the more of the particles are on top of each other. So you'll have brighter towards the center of the effect, and you'll have more various colors towards the edge. Whereas like a smoke particle, you might want multiply so that it's kind of just the dense smoke color all around. You'll need to play with these to find the right application for your game. And finally we have these two Sprite materials. You'll see the first one, the green cross here, uses a shader in the sprites, a tab called default. This is your default 2D sprite. It just takes a sprite image and displays it in the world. You can see it displays it on both sides. So this is what gets used when you apply a sprite renderer to your game. These are not cubes. These are just flat sprite renderers. If you look at the sprite diffuse game object and the material applied to that sprite renderer, this one uses a sprite with that's called diffuse, which will allow it to interact with light. So again, it's a 2D sprite using a sprite renderer component, but only the side that's in the light gets lit up, while as the rest is dark. So this is a way you can kind of give your sprites a lighting effect in your game. Alright, so we've looked briefly at several materials and examined a few of the different shaders we can use in our games. We learned how to apply texture maps to PBR materials to give them intricate details, how to make see-through materials like glass, and how to use a few particle materials. Next we will look at the various lighting options that Unity offers us. Okay, now we're going to navigate to the lighting scene inside of 3.3 lighting. And here you can see I have a demo scene with a bunch of different types of lights set up. So we're going to go through how each of these were implemented and how you can add them to your game. Alright, so this scene makes use of several lighting and shadow systems. We're going to start over here. The spinning lights here are real-time point lights with a script attached to rotate them. Point lights cast light in all directions around them, with the distance and intensity being set in the inspector. Change the range of the light, the intensity. As you can see, the revolving cube is being lit and casting shadows as it passes the lights. These are expensive calculations, and their performance costs should be calculated carefully, especially when targeting mobile and web builds. It's also important to note that any mesh can only be lit by a few real-time lights at once before lighting glitches appear, so take that into consideration when using real-time lights. Next, we're going to navigate over to the purple spotlight. The purple light pointing towards the ball is a baked spotlight. The spotlight only casts a light in certain directions, unlike a point light. This can be set here in the inspector with the angle and the range. The direction is based off of the rotation of the light's transform component. So to aim the spotlight, you have to rotate the game object. Now because it's a baked light, you're not going to see real-time updates here. Baked lights are drawn onto the surface of static meshes in the scene at the time of baking. As you can see, we add a new sphere mesh and drag it into the light. It will not be lit by or cast shadows from the baked light. So here you can see this mesh I just added. There's no interaction from the purple light with it. This is because the light is a baked light, and this sphere wasn't here when we baked the light map. If we wanted to add this sphere to our light map and have the purple light appear on it and cast a shadow from it, what we would need to do is set the mesh to static. Static mesh can be set up here in the inspector by clicking on the static toggle box. And what this means is this mesh can no longer move in the game. You can move it in the scene, but during gameplay it's locked where it is. Once it's static, and then you build your light map, which we'll get into shortly, this mesh will appear in the light map and be allowed to interact with the baked light. Okay, so let's look at how we can update our light map to shine on this new sphere we added. Remember, we marked it static so that a baked light can be used on it. Next, we have to go into the lighting tab. If you don't have one, you can drop down the window menu, go to rendering, and lighting settings. Now this is full of all kinds of settings that you can experiment with to set the lighting in your game. Mine have already been set from previous bakes, so now I'm just going to go down here and generate my light map. This can take a few minutes and your computer might run hot and be kind of unusable for a few seconds, so we'll come back after that's built. Alright, so now you can see our light map bake has completed, and our sphere now has the purple light shining on it, and it's casting a shadow back here. It's a little tough to see, but... So this sphere has now been added to our light map, and we'll take a look at that light map here. If you open up the Baked Light Maps tab, and open preview on one of your light maps. So a light map is just kind of a texture that shows where all of the lights in your scene should appear. It's not very human readable, but you can see here where my purple spotlight is. Take a look at the other light map as well. There's some more purple. So basically when you bake your light map, you're generating these textures with all of the light details for your scene. And when you add an object that you want to add to your light map, you have to rebake it, which is redraw these textures, so that when they're updated, your new object shows up where it's supposed to be. Okay, the next light we're going to look at is a directional light. So this is the light outside the window here. A directional light works kind of like the sun would. It casts a light everywhere in the scene from a certain direction. Now it doesn't matter where the light is placed. As you can see, if I move it up and down, nothing changes. But its rotation determines the angle of the shadow. The final light source in this scene is this green bar running across the floor. This light does not use a light component, but instead has a material with an emissive value set quite high. This causes light to be emitted from the face of the mesh on which the material is applied. The brightness of these light sources is set by the intensity value of the emission color. So if I select the game object, go to the mesh renderer component and choose the light bar material, open that in the inspector, and we can see the emission field on the material as this green color. And here is the intensity slider, which determines how bright light should be. Now, because this is set to a baked light here, when we turn the intensity down, you can still see the glow that is baked into the light map. If we wanted to get rid of that, we would have to turn the intensity down and then rebake our light map. Alright, so now we've had a chance to look at how to add mesh to Unity, how to apply materials to it, and how to use the lighting systems to light your scenes. I'm going to go through a little bit of everything we learned, just as an example of each. I'm going to start with a new scene. So here we have a new empty scene. I'm going to add in some meshes, do a ground with a cube. And I'll do another cube that will make a building. Alright, so we have a ground and a building. And we have the default directional light that comes with a new scene. We'll just leave that for now. We need to create a material for the ground, so I'm going to create a new material. And I'm going to apply it to the ground by dragging it from the assets onto the ground. And because this is a new material, it starts with the standard shader, so I can just start plugging in some textures. And using this tiling field, I'm just going to put a higher number so it's a little bit smaller. Alright, now for our building, I'm going to create another material. Again, it's using the standard shader, so that's fine. We will look for high rise. Oh, first I'm going to drag it on there so we can see the changes in real time. I think that's supposed to be height map. And remember, our building has that emissive texture, so we're going to throw that in there too. Now you can see it's kind of squashed on the x-axis here, so I'm going to set the tiling to 0.5. It gives us a little bit better look. Alright, so now we have two meshes with two materials. Because this is kind of static objects, they're not going to move. Our building and our ground aren't going to move. I'm going to use baked lighting on these. So the first thing I have to do is set both of these game objects to static. I'm going to select both of them and click the static button up here. And now that will let the baked light mapper render them in the light map. I have to then go to my directional light, and I'm going to set it from real time to baked. And that should be okay there. So now I can go into my lighting tab, click generate lighting. Alright, once our bake is done, you can see we have a shadow on the ground. And that's our baked light map. Now I'm going to add a sphere. This we're going to do a real-time light on. I'm going to not set it to static. First I'm going to create a material for it. I'm going to increase the tiling and add in the other maps. We don't have an occlusion map for the wool, so we'll leave it like that. You can see it's dark right now because remember it's not part of the baked light map. So we're going to add a point light. Put it somewhere next to the sphere. And I'll give this a green color. Bring the range down, but the intensity up. Try to keep it off the building, mostly on the sphere here. Alright, so this is going to be a real-time light with soft shadow. Indirect multiplier, that only affects baked lights, so we could set that to 0. Alright, you can see we have the real-time shadow from the sphere. You can also see we're casting a shadow from the building. If we want to disable that to save on memory usage, we can grab our static objects and just turn off cast shadows. So now you can see the real-time light doesn't cast a shadow, but the baked light map is still there with the shadow on it. So this allows us to kind of focus our real-time lights only on the things that we want them to show up on. Alright, so that's a scene that uses everything we've learned in this lab. There's a lot to experiment with on your own here. Materials and lighting are very complex subjects. This is just kind of an introduction to them. So you can take what you learned here and start applying these concepts to your Lab 3 project, and hopefully we can see some interesting looking games come out of it.